So this has the point. Well, first off, remember they go opposite order. You take the one at the end and you put it up to the front. And it's not positive 4, it's negative 4. And then this one goes here and it's positive 3. You don't have to put a plus. We all know if there's no plus, it means positive. Raise your hand if you had that one right. Awesome. And then the slope, I hope it's obvious. It's sitting right there. But what's its rise and what's its run? Yes? 1 rise, 2 run. All right. So if you had to graph this, I want you all right now to use the 3 dots, template settings, and get a grid up on your blank Notability doc. Make it a grid. Do that now. Some of you aren't hearing me. Get graph paper up on your iPad by using the 3 dots. And then it says template, and then you pick a grid. Now graph this thing. In case you got a short-term memory issue, the slope was a half. The point is right there. Graph it. All right, I'm going to pause for a second while you get graph paper up and graph it. All right, so what if I had just given you this equation, or this graph, and I didn't even give you an equation at all? Couldn't you make one from having 2 points? I have this point, I have that point. Couldn't I have made an equation for that? Yeah, and the first thing you should go to, I'm telling you on the worksheet today, every time I got asked, like, I don't know what to do, my response was, write this out. And then just fill in the blanks. Like, do you know what the slope is? Well, no. Well, look at it. I can see the slope. It rises 1, it runs 2. So I know where the slope, what the slope is. Because I can just look at the 2 points. And I know my slope is a half. And then, but I don't know the point. Well, look, you've got 2 points. You could pick either one. I personally would pick this one. Doesn't matter. I'm picking that one. -2, 4. That's the point, -2, 4. And instantly I've got my equation. Y minus 4 equals 1/2 times x, and notice there's a minus minus, x plus 2. There, that's how you write an equation for a graph. Pick 2 points, you'll be able to find the slope, you'll be able to stick it into that big equation. And one kid asked me last hour, are you going to give us that equation? Yes, we are. This is going to be on the top of your test. But it's up to you to know when to use it. And I can honestly say, almost every time somebody got stuck, the answer was, write this down, stick the numbers in. All right. So then another skill that's critical is, do you know how to be parallel and perpendicular to something? Let's say I put an 8 here. What slope is it right now? 8/1. And if I wanted it to be perpendicular to this, I would use -1/8. You gotta flip it. Yep. Negative is correct, and 1/8. All right. So that's the parallel and perpendicular thing. How about just finding a slope between 2 points? Oh, I hope that's too easy for you. But let's just do that. I'm going to give you 2 points. 2, 8, 10, 12. Would you find the slope between those two? And then make it into a line. Hint, copy down that equation I just said was the most important equation of them all. Y minus y1, blah, blah, blah. But first find the slope. So while you're doing this problem, I think you can hear a story at the same time, and you probably can do both. My sister right now is alternating between crying and praying. You know why? She has a house on the west coast of Florida, and there's a hurricane that is going to hit there between now and 2 in the morning. Somewhere in there, it's going to hit. Last time I checked, it was back to a Category 4, but it was a Category 5. Either way, the difference is like 185 mile an hour winds or like 165 mile an hour winds. And if you want to get perspective on how bad that is. Imagine, have you ever stuck your arm out of the window when you're going like 60 miles an hour? It's like really hard to hold your arm in place. It like wants to blow your arm off, right? That's 60 miles an hour. Imagine tripling that, 3 times that fast. And then imagine stuff's in that air, because the air isn't just nice clean air. It's got like sticks, it's got like cars, it's got like broken glass flying in that air. Can you imagine being in that kind of a situation? And yet, the crazy part is, for a hurricane, most of the damage doesn't even come from the air. You know what it comes from? The water. Because something called storm surge. It artificially raises the level of the ocean by pushing water super hard, all like, if you just like imagine blowing on water, except incredibly fast, it would blow it out of the container, right? That's like blowing it out of the ocean and onto shore. And it blows so much water in there, they're talking about a 10-foot storm surge. Just for perspective, this room's only 9 foot deep. So, like high. So imagine it going deeper than this, and the water is filthy again. It's got cars in there, it's got dead things in there, it's got sticks and branches and mud, and it's just gonna plow over her condo, and she knows that her condo is pretty much toast. There are gonna be some crazy people too who are gonna stay in their condos. And they're gonna, if you're on a lower level condo, you probably won't make it, literally. They think that they'll be fine because like, oh, the last hurricane I was fine. This one's going to hit a different area. There's going to be some people that will die because they're too stubborn to leave. So anyway, that's what's happening right now. I'm going to have a problem about that you have to interpret the slope. Because you just figure out the slope, and then you figure out what it means with units. Like, is it miles per hour? Is it speed per second? You have to figure that out. All right, so your slope on this one should have been 12 minus 8 over 10 minus 2. And 12 minus 8 is 4. 10 minus 2 is 8. 4/8. Would you agree that's 1/2? Raise your hand if you had a half. Okay, good. Then that's your slope. Can I just be done? No, you need the whole line. Y minus, now, I don't care, but I want to know which point got used more. Who used 2, 8 as your point? Who used 2, 8? Who used 10, 12? All right, it was more 2, 8s. All right, so here's what you do. Y minus the 8 equals the slope, 1/2, x minus the 2. Notice that 2 that was in the front goes all the way to the back. It was a positive 2, it becomes a minus 2. That making sense to you? But you say, Mr. Server, they didn't ask for point slope. They wanted slope intercept. You'd still start with this, and then you solve it. So would you please take a second and solve this? If you need a calculator, get a calculator. It's 1/2 times x is 1/2 x. The other one, 1/2 times 2, it's just half of 2. You probably don't even need a calculator for this one. But multiply it all the way out. And then I'm going to get to the tricky kind. Last hour, mostly they stared at me. We'll see if you can figure out the slopes of real-world problems. All right, let's see. Moseman, when I multiply this thing out like this, what did you get? Distributing. Oh, wait, 1/2 times the x. 1/2 x, and then -1 was correct. Half of 2 is 1, so yeah. Now I'm going to bring this down. So, Maddie, how do I solve it? It's not solved yet.
Add the x to the -1, or add the 8.
Add the 8. There you go. And now we have y equals 1/2 x, and then 8, and the -1 makes +7. Raise your hand if you had that one right. Okay, awesome. And now for the slope. Well, if I just said what's the slope, you'd be like, duh, it's 1/2. What if you wanted to be parallel to that? What do you use? So if I write y equals 1/2 x plus 8, do you agree those two lines are parallel? Yeah, because they got the same slope. What would you call it? I'm going to reverse the question from normal. If I use that slope, what are these two lines now? Perpendicular. Good. I used the opposite and flipped it. That's called perpendicular. All right. So now my storm question. Do not copy this graph. You can just listen for a second. If the storm, would you agree the storm will eventually slow down? Do you agree that eventually storms slow down? They don't go 165 miles forever, right? Okay. So then, if it starts out at, let's say this is 200 miles per hour. Now that would be crazy. I don't think there's ever been a storm that fast. But if I count by 40s, let me see if this will work. 40, 80, 120, 160. Yep. 40, 80, 120, 160, 200. Okay. Now what they're going to hope is that this thing at, let's say it goes crazy and it hits 200 miles an hour, which would be one of the fastest ever in history, hurricanes. And let's say it does this over the first 3 hours. Would you agree that there's a slope? Can you tell me the slope? And hint, you're going to want to figure out the rise and the run between here and here. And you need to use units. Like, this is hours. And this is the speed of the wind. I'm just going to say speed. Do you get how my hurricane question is up to date? It has to do with something happening today in Florida. I'm trying really hard to show you how this math could happen in the real world. So, would you agree that my slope is negative? What do you think that means about the wind speed? Do you think it's speeding up or slowing down? Slowing down. Okay. So then how do you answer this question? The question is, what is the slope? And use the context of the problem. So you not only have to give me a number answer like 1/2. That is not the right slope. You figure out the rise, you figure out the run, and then you'll have your number. Then you got to say it in units. Like, the answer is, I'm not going to use the right answer here, that we're going to lose 60 miles every hour. That'd be an example. So how much rise was there? Oh, there isn't a rise, it's falling. How much run was there? Oh, you could count, can't you? And then figure out what the units mean. All right, I need to give you 30 more seconds to figure this out. Okay, take a second, and I know this is one of the hardest questions, but realize it's only one of those where if you get it wrong, you just don't get the 5%. You get 5% added if you can figure out this kind of thing. So talk about how much it rose, talk about how much it ran, and then what you think the final answer is with the kid next to you. Okay, I kept saying rise over run, right? So here's the rise. Well, it isn't rising, it's falling. How much did it fall? Look, it went down to 120 from 200. How much is that falling? If it goes down from 200 down to 120, would you agree it went down 80? All right. Then it goes from here over to here. How long did that take? What was the run? It was 3, see? And what were these? Chickens? No. 80 was speed. And this was hours. So if you had said that the storm slowed down 80 miles per hour over 3 hours, that's a rate. Now, if you could simplify this, I would, but I don't think 80 and 3 work out nice. Now, what if you had a calculator, though? Here, you'll have a calculator, right? What is 80 divided by 3? 26.6 repeating, so 26.7, I could round that to. The minus, don't forget the minus. It's slowing down 26 or 27 miles per hour. Every hour, it slows down about 26 miles per hour. All right, so that's an example of, it's just a slope. It's just a rise over a run. It's just got context of a real world problem. Okay, if you get stuck today, promise me that the first thing that you will do is go, like sometimes they give you 2 points and kids get stuck. Well, then make this equation and figure out how to make it work. And you'll go, oh, I guess I need a slope. Oh yeah, I can figure out the slope. And then if you wanted to, you've got 2 points, right? You could take one of the points and stick it in here. 2 goes here, 10 goes there. So if you get stuck today, try to figure out how to make this equation be the answer, because it almost always is. Okay? Even if you want that other form, even if you want this form, yeah. If you want this form, you still start with this form. And then you just multiply it all out. Okay, so if you get stuck today, try to make this work. All right, and that's all I got for you for the video for today.